Hey, going to talk about similar figures again, similar shapes. And specifically today, we're talking about the perimeter of similar figures and the area of similar figures. All right. How is perimeter affected when we scale an object, when we make a similar figure? Let's look at this smallest rectangle over here and let's count up the perimeter. So we have a side length of 1 and 1 and 2 and 2. So that's a total of 2, 4, 6. So the perimeter equals 6 in this case. All right. So we're going to compare it to the perimeters of the other two shapes and see how the perimeter is affected. First, I want to look at, before we do that, I want to look at the side lengths and compare the corresponding side lengths. So this short side here corresponds to this side of 2, and then this longer side measures 2 units, and its corresponding side would be 4. All right, so what we're going to do is we're always going to put the new shape, what we call the image, on top when we're trying to find a scale factor or looking to set up a proportion here. So since we went from here to here, we're going to put the new shape, the 4, on top. So 4 to 2 and 2 to 1, right? Those are equal. Their side lengths, corresponding side lengths, are proportional. And when we divide that, we get a scale factor of 2. All right, scale factor of 2. So basically the side lengths of the original shape over here, this shape, the side lengths were multiplied all by 2 to get this new shape over here. All right, when we do that dilation or enlargement. Okay, so now let's count up the perimeter and see how that's affected. All right, is it affected by the same scale factor of 2? Is it going to be 12? Let's check it out. So we have 4 down here, 2 over here. That's 2, 4 plus the 8. That is 12. All right, so we see that that's going to be 12 units. So right now it looks like the perimeter is just affected by that same scale factor that all the side lengths were affected by, which, if you think about it, makes sense, right? This original 2 right here went to 4. It doubled by the scale factor and or multiplied by 2, and then the 1 to 2. So if all the side lengths doubled, it stands to reason that the perimeter would also double. Let's now check out this next one. All right, so instead of going to that middle shape, we're going to jump all the way over here. See if you can figure out the scale factor. What were all the side lengths multiplied by to get this new shape here? Well, it looks like this is 3 and this is 6. So if we put the new shape on top, the new shape lengths on top, so that's 6, and its corresponding side would be 2, and 3 to 1, we can see that that gives us a scale factor of 3. All right, so now let's see if the perimeter is affected by that same scale factor. Let's fill in the other sides. And we have 6 and 6 is 12, plus another 6 would be 18. Is that 6 affected by the same scale factor? Is it times 3, just like we said over here? All right, yeah, 6 times 3 is 18. So the perimeter is just multiplied by the same scale factor that all of the side lengths are multiplied by. Okay? So the perimeter is actually proportional with the side lengths. If you compare the new perimeter to the old perimeter, it would have the same comparison in a ratio as the new side lengths to their corresponding old side lengths. Okay? So that's pretty straightforward. The tricky part comes when we talk about area. All right. Like if I were to say to you, oh, how many times bigger is this shape than this shape? Excuse me. How many times bigger would this shape be than the original smaller shape? All right. And you might see, if you look at the side lengths, you might say, oh, it's 2 times bigger. But if you look at the space that the shape actually takes up, you'll probably say something different. All right, and let's look at that a little more closely. Okay, so this has an area of how many square units? We have 1 square unit, 2 square units, or we could just do 1 times 2, which gives us 2. 2 units squared, or square units. All right, now how many times bigger is this other one? Is this next shape up? Well, we saw that it had a scale factor of 2 because the side lengths all doubled in this original problem, right? Scale factor of 2. But is it 2 times bigger when it comes to area? When it comes to area, all right. Well, let's look at it. There's 1, 2, 3, 4, 5, 6, 7, 8. No, it's 8 units squared, or square units, and that, if we look at this, that doesn't follow the same pattern as the scale factor. All right, it is not gonna be just multiply the area by the scale factor and get the new area. So what we'll see here is that it's actually, right, two more of those original blocks fit along this side length, and then 2 more fit along this side length here, right? So then it's kind of like 2 times 2, and that gives us, it's actually 4 times bigger, right? So the scale factor, and this isn't mathematical, I call it the area factor, but this is multiplied by 4, all right? Whereas the perimeter was just multiplied by 2, right? From the 6 to the 12 was just times 2, which was the scale factor. But here, it's times 4, which I call it the area factor, but it's not really called that. But we'll see that when we are looking for how the areas compare, all right, it's going to be actually the scale factor times itself, all right? So if I look at this, let's do a different color. All right, so what was the scale factor? The scale factor is 2, and how does that relate to this area factor, what I call the area factor? Well, it's actually the scale factor times itself. All right, so we'll see this pattern happening over and over again, and so we can make it into kind of a rule, but the area factor is always just the scale factor times itself. All right, the scale factor times itself, or we can say the scale factor squared. All right, so the area factor is just the scale factor squared. Let's see now, erase a bunch of this stuff. Oh no, let's leave it. Okay, let's go find a new color just to switch it up a bit. All right, so if I am now going from there to there, all right, we see the same idea as the perimeter that we talked about earlier. Okay, we see the scale factor is 3, 1 times 3 is 3, 2 times 3 is 6, and the perimeter was affected by that same scale factor. But now, if we look to the inside of the shape, it doesn't really look like 3 times bigger. It looks like a lot more times bigger than 3. And we can see that, well, if this side length was multiplied by 3, that means we can stack 3 more of these boxes in that space. All right, but also the other side length was multiplied by 3, right? So then we can stack, or we can sit 3 of that shape next to itself. All right, and then we get this, array. Remember arrays from when you first learned multiplication? We have a 3 by 3 set of that original block, that original rectangle. So that actually gives us an area. if we end up counting all the blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, that gives an area of 18 units squared, which if we look from the original area, 2 times what is 18? 2 times 9, right? It's times 9. Does that fit this original pattern over here where, okay, if the scale factor was 3, right? What's that area factor? I'm thinking about it in quotes because it's just my own label for it, but what's the area factor? The area factor is 9. Does that fit our pattern right here of the area factor always being the scale factor squared? Well, what's 3 times 3? That would be 9. So the area factor, which I call it, is 9, which is just the scale factor squared. 3 times 3. Okay? So that is just a brief introduction. Might not have felt so brief to you, but that is a brief introduction of how area is affected when we're talking about similar figures. Okay, so it's not just affected by the scale factor. It's actually affected by the scale factor squared. All right, so that's our intro to perimeter and area of similar figures. And we'll do some practice and try to apply this idea.